Okay. All right, here we go. We are going to now be doing 4-3, which is determining whether it's proportional or non-proportional. All right, so we're going to fill in a few notes about some things first. Okay, so if the ratios or rates of two quantities are equal, okay, or the same, then the quantities are proportional. So if your ratios or rates are equal or the same, then it is considered proportional. That means all of your rates or ratios in a table. Okay. If the ratios or rates of two quantities are not equal, then the quantities are non-proportional. All right, so let's see what that looks like when we're looking at a table of values. Okay, remember, if it's not equal, or not the same, it is non-proportional, not non. If they're the same, then it is proportional. If they're equal, then it is proportional. All right, here we go. So what I'm going to do here is, it says, Eric and Lucy ran 20 minutes each on the treadmill at the gym. The table below shows the number of calories each has burned after 5-minute intervals. Complete each table and determine the type of relationship. So my rate is going to be calories per minute. There's my word ratio, and it's going to be the same for both Eric and Lucy. I'm doing the calories per minute to figure out my rate. So again, we can do this division. So I'm going to be doing 70 divided by 5. So I'm going to come over here and I'm going to do that division. 5 into 70. 5 goes into 7 once, with 5 left over. So this is 5 goes into 24 times. So this is 14 calories per minute. And I'm going to do that division for all of them. I'm going to have 140 divided by 10, which is going to give me, the zeros cancel. So that's going to give me 14 calories per minute. And you cannot assume by, oh, those two are the same, I'm done, it's proportional. You can't do that. You have to work all of them. So we have to do 210 divided by 15. So I'm going to come over here and I'm going to do that division. 15 into 210. So that's going to go, 15 goes into 24 one time, 15 with 6 left over. 60, 15 goes into 16 4 times evenly. So that's going to end up being 14 calories per minute. And then we have the last one, which is 280 divided by 20. The zeros cancel. So I've got 28 divided by 2, which is 14 calories per minute. So this one did end up being, okay, the same for all. Sometimes it will trip you up and it's going to be that last one that's not going to be the same. So now I'm doing this same information, but for Lucy. So I'm going to have 45, not 49. My brain's already thinking about the division. 45 over 5, which gives me 9 calories per minute. And then I've got 90 over 10. This cancels. So I have 9 calories per minute. Then I have 120 divided by 5. I'm not sure about that. I come over here and I do that division. 5 goes into 12 twice. 10. 2 left over brings 5 goes into. Oh, that's 15, not 5. No wonder my stuff was off there. Okay, so we've got 15. What if I just do my counting? 15 is 30. So that's 30, 60, 30, 60, 90. And another set is 80. So this is going to be 8 calories per minute. And yes, you know right off these are not the same, but you have to finish your math. You have to finish your calculations. So I'm going to have 180 divided by 20. The zeros cancel. 18 divided by 2 is 9 calories per minute. This right here is different. That's what causes this to be non-proportional. All right, now let's fill in the blanks here. Okay, it says the calories burned by Eric is proportional to the time because every ratio is equal to 14 calories per minute. Now let's talk about that glare. I don't know if it comes out on the video or not. Kind of is disheartening. Let me see if we can do it this way. Maybe that takes it out. It does. Okay, we'll just have to do that. Okay. All right, so the calories burned by Lucy is non-proportional. It is non-proportional to the time because of that 8. Because, and we have to be able to give the reasons, because the ratio of 120 to 15 is not equal to the others. All right. When we're looking at number 1 here, it's determine whether the quantities in each table represent a proportional relationship. If yes, give the constant rate. Okay. Well, when we think about this, we're going to do our word ratio first. So we're going to do the students. It's the students per bus. So we're actually flipping this and doing the students over the number of buses. So for number 2, this is where it's important to write the word ratio. You have to think about, when you think about your hourly wage, it's the money per hour. It's the money per hour for your word ratio. You have to write the word ratio, and then it helps you to know how to write your rates. Okay, flipping over and moving on to the back. Number 7. Okay, it says if the following tables represent a proportional relationship. So we already know it's supposed to be the same all the way through the ratio. So that gives me some information. So it says complete the table. Ben earns $8.50 per hour bagging groceries at the grocery store. So in order to figure this out, that means the number of hours is my X in a way. I can think of this as, okay, I'm going to do $8.50 times the number of hours. So I'm going to have $8.50 times 4. 4 times 0 is 0. 4 times 5 is 20. Carry my 2. 4 times 8 is 32 plus 2 is 34. There's 2 decimals. So therefore, the answer for this one is 34. And then we have $8.50 times 8. Okay, so I've got to do that multiplication. 8 times 0 is 0. 8 times 5 is 40. Carry my 4. 8 times 8 is 64 plus 4 is 68. So this is 68. And then I'm doing $8.50 times 10, which is 85. And then I'm doing 8.5 times 14. 4 times 5 is 20. Carry my 2. 4 times 8 is 32. Plus 2 is 34. Put my 0. 5, 8. Add 0. 9. 11, one decimal place, and we end up with 119. Your assignment is to finish the notes and complete the classwork homework. Let's do the odds. And then, of course, the evens will be your extra credit because there's quite a bit of calculations that have to go into this. Okay, y'all have a great day.